says A, a B, or C, a D, clearly. Go on here a little bit, or let's, you're frozen. Okay. All right, let's, I don't know. You're good. No, you don't. Okay, so, how did you eliminate, or I feel like the first one I found was A, because I started at the top.
The way that I found that one is because since y is the only variable, I knew that all the horizontals in a row would have the same slope. So
That's this one.
Yeah.
Okay. All horizontal slopes are the same. Okay, is that pretty much how you all got A quickly? Good, very good. Okay, what about the rest of them? Because I feel like I went and checked out 0, 0, okay? And then when I did 0, 0 for B, I got 1. I did this backwards. Okay, so when I get, here's 0, 0, here's 0, 0, here's 0, 0-ish. Okay, so this has got to be B then, right? So it eliminated these two. All right, now 0, 0 looks like 0 slope on both C and D. Okay, so 0 minus 2 times 0 is 0. Okay, 0. Okay, so we can't eliminate by C and D with the 0, 0. What did you do next? Cindy?
Well, I did the bottom right one first, and I just went
1, 1. Okay, that's exactly what if I remember correctly. And for D, for this one, or let's see, you have 1 minus 1, you have 0. Okay, for D. And for, or what am I doing? Yeah, for C, you have a -1. Okay, that's really unorganized, but anyway. So 1, 1, 1, 1, is that 1? Right here. Okay, there's a 1. Where did that go? That's a 0. Okay, so that clearly is C, and that is D. Okay? So sometimes you can eliminate, sometimes you can confirm, but you have to go through and make sure that, you know, you're not falling for one little thing, and then it's like, wait, that also works for that one, and that one, and that one. Okay, so anyway, good job. So this is a matching you would probably do on the AP test. You would probably say, all right, find the slope field for A, and then it would be, here are your 4 choices, or find the slope field for B, and then you would have the 4 choices. It also could be, say, here's your slope field, which equation is that? And you'd have the 4 choices. So it'll go both ways, but that's primarily the way the slope field would work. And then there also is another piece where they'll say, okay, do the whole slope field with these 6 points. And then they're just looking at the whole slant and negative, positive, you know, steeper, whatever. Okay, so we have the points, -1, 1. We have the slope field already done, okay? The computer generated slope field. All right, go ahead and sketch the solution curve that passes through the point -1, 1. So this would be 7-2 lesson still. We're just kind of easing into a different lesson here. Do I need to block you, anyone?
No.
Okay. Your solution curves look really good so far. Yours look like that looks great. Very good, very good. Nice. All right, very good, girls. You did it. Everybody's good. So you went here, and then you said, maybe this way. Yours were a lot better looking than mine, but anyway, that's your, kind of did an icky bump there. Let's fix that. Okay, good. All right, so what we're going to do today is we're going to learn how to do that one. Okay, these are called as in solve that particular slope field. We weren't able to do that before because of the y being in there. Usually it was like dy dx equals x squared, da da da, and then we would say, all right, do this, and we have the y over there, we have the blah blah blah, x squared, okay, and we're done. All right, now the difference here is the y squared. So these are a little bit more specific. The separable differential equations are the equations that can be separated when solving. Okay, so this is kind of the, you have to kind of go with it, but write the equation in terms of differential, write dy dx instead of y prime. And you'll see why, because what's going to happen is we're going to separate the dy from the dx. Dy is going to be on one side, the dx is on the other side. Okay, so that's the next step, is to separate your x's and your y's. The dx will go with the x, the dy will go with the y. Because when after we manipulate so that the x's and the y's are together, separate but together, remember the y will have dy with it, the x's will have dx, okay? Because then we'll be able to integrate with the blah, 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 dy, blah, 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 dx. That's what you're going to be after, okay? And then you'll solve your particular equation for y, okay? So let's try that one that we just did, that we had the slope field for. We're trying to find the general solution, and then we're going to find the specific solution through that -1, 1 that we drew the solution curve to. Okay, so it's written in terms of dy dx, so step 1 is already done. Okay, separate. Any suggestions of how we could separate dy from dx and x squared from y squared? We have to do algebra, correct algebra. Very good. Y squared dy, x squared dx. Cross multiply. Okay? Now, it doesn't make sense to put the dy at the beginning or the dx at the beginning, because remember, next step is to what? Integrate. That dy just reminds you, you've got a derivative and you have to find the antiderivative deal. Okay, so integration. Let's see. Allie Creevy, could you integrate y squared for me? Okay. And how about Lindsay, x squared? Okay. Interesting fact. Neither of you talked about c. Which one should be this? Where should we put the c? Because if we put c on both sides, it's like now having a c, right? With the x, yes. Put the c with the independent variable. It's not always going to be x, but more often than not, it's going to be x. Okay? Just because that's what we're used to. Don't put it on both sides, because then they cancel each other out. That's just not going to work. Okay. We got integrated. Last step is to solve for y. Alrighty. How do we solve for y? What's the first step? Multiply by 3. Alrighty. Now, 3 times a constant is still a constant, right? Yeah. Okay. Now you can use 3c, and I'll show you why. If that algebra really bothers you, we'll do it that way over here. Okay, and then I'll show you what happens to it. Okay, so keep solving for y. What do we want to do now, Molly? No, I'm not solving for y, darling. I got to solve for y first. I got y cubed. Cube root, yeah. Okay, cube root of the side. If you were doing it over here, it would be cube root of the side as well. Okay? So that's your general solution. I'm going to kind of circle that because I want to make sure that I know that's where I'm going back to. Now you are going to plug in, what was it, -1, 1? All right, so here we go. 1, -1, solve for C. Okay.
So we have to keep that.
I'm doing this side. I assume y'all are doing that side. Okay, I know you didn't get the same C because we did it differently. What did y'all get for C? You got 2 and now 2/3, right? Okay, did anybody not get C? Okay, C goes back into your general solution. We've done this before. So Y equals, what's my equation? Cube root of x cubed plus C. Okay? All right, now over here, because some people are like, I'm really bothered by that multiplication, I'm just going to ignore that. Then I worked with the C, here it is, but my C ended up being 2/3. So when I put it back in here, look what happens. I have to multiply the 2/3 times the 2. It's really delayed. Okay, and I get exactly the same thing. Okay, so you can do it if that C thing bothers you or makes you kind of crazy, then just go over here. It's just a little bit more complex when you put it in here. But you can't, be careful wherever you get your C from, that's why you need to kind of know, oh, well, that's where the C goes back in, or it goes back in here. So just be careful. Any comments, questions on that? You've done that piece before. Go ahead.
Are they ever gonna ask you like what this is?
No. No. No, they're either going to ask you for the general solution, which is right here. That's a good question, though, Sarah. This is your general solution, and this is your specific solution involving -1, 1. Okay?
The other way.
Well, not really.
I know, but that wasn't, like, would they have that as an answer to?
Probably, they wouldn't have both of them, no. That's a good question, but no, they're not going to have both of them because they would, both of them could be right depending on how you did it. Most of the time, if it doesn't matter, if you still get a constant when you do it, then they're probably going to do this way instead of the 3C. If you can get used to that, you're probably better off. Okay? All right. Now, I wanted you to look at, before we move on, go ahead, get your calculator out, and put that in your y equals. I want you to look at it, and set up your window to -3 to 3 on both x and y. You're going to be amazed. Window, -3 to 3. Doesn't matter what the scale is on either. All right, y equals, what was it? Cube root, so that's a math. Cube root number 4. X cubed plus, oopsie, plus, oh, for gosh sakes, huh? Plus 2. Look familiar to you? Surprisingly accurate with just the slope field. But that's the beauty, if you will, of the slope field, is you can take any solution and get a graph of it. This is the graph of all solutions. This is just one that particular wants to go through, you know, wherever that negative 1, 1 was right there. Okay? So, anyway. All right, so here's the slope field. I think I did this one by hand. All right. We're going to find the specific solution of the differential equation of this, okay? And then we're going to graph it on the same coordinate axis. You want to graph first or you want to graph later? You know, let's graph first. Okay. So graph the solution with that negative 1, 1. They're kind of far apart. So do the best you can. And then we'll graph this one. There's kind of an unknown right there that you probably don't see right here. It doesn't look like there's anything there, but if you look real closely, there is a horizontal line right there. Can't really see it unless you really look for it. It's a little, okay? So that might help that graph a little bit. And I would be quite surprised if you all didn't think, wait, if your slope is 2x, the antiderivative of 2x is what? X squared. I would be quite surprised if your brain did not go there. Okay, now go ahead and solve for general solution first, and then specific solution, negative 1, 1. The closer your things are together, the more accurate your graph is going to be. But yeah, if you're graphing it, you're all done. You're graphing it, it's a little bit more tedious to do. What's the matter? What? Bring forward. All right. So d by dx becomes what when they're separated? Okay, you might want to put a 1 in front of that, just to remind you there is. So that would be y here equals x squared. Don't forget your c, because if you don't have your c, you don't have anywhere to plug in, but it just becomes weird. Now there's your general solution. It's already solved for y. Now you plug in your specific solution, get your c. C is 0. Specific solution is y plus x squared. Okay, say this was on the AP test, and if you finished, you forgot the c here, and oh wow, you get the same answer, so it didn't even matter. Yes, it would matter. If you don't put the c, they're done with you, and they won't give you any more points. The c is very important, even though without the c, we would have got the same thing. Okay, that doesn't happen that often, so don't forget your c. Yes?
Is the only reason you can't just like differentiate from the beginning because you're looking for
We are differentiating from the beginning. What do you mean? I don't understand what you're asking me, I guess. because we did differentiate this. Now, we could have done this in 7-1 because we would have had this, and then we did this, and we got this, la 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 la. So that really isn't that much of a differential. We're just putting it together with the slope field now. Okay? All right, let's try. These get kind of weird. All right, general solution. Go for it. I'm going to pause it for a little. Back up here. Okay, so we have dy. We just did a simple cross multiplication. Now, the 2x, I want to stay where it is. How do I get this over to this side? Alrighty then, here we go. Now, I wouldn't put it under the dy because that's just weird. So that's what you have, 1 over radical y minus 1 dy and 2x dx. Okay, this side's a piece of cake. Let's go ahead and integrate. What is this side? Let's see, good job. Okay, now over here, we got to do some u substitution. What's u need to be? Or we could do, did any of you pull it up to be y minus 1 to the negative 1/2? Okay, so u is still y minus 1. Du dy is what? 1, so du and dy are the same. So this is now going to become du. This is now going to become u to the negative 1/2. Okay, so now we have u to the negative 1/2 du to integrate. What is it? 2u to the 1/2. Okay, and u, this is an antiderivative, so u's got to go back in. So y minus 1 to the 1/2 equals, pick it up where we left, x squared plus c. Okay, did I lose anybody? Alrighty then, let's see. We're going to solve for y. What do we do first? Divide each side by 2. A constant divided by 2 is still constant, right? So I'm going to leave that as c, and this is now y minus 1 to the 1/2, which you might recognize as a radical. Okay? So what do we do now? Square both sides. Now this c is going to have to be under the squared, so y minus 1 equals. We cannot square individually. That's not how squaring works. We FOIL that square. Okay, so what's y? That's 1. That's your general solution. Do not just multiply that out and get c to the second. No, just leave it just like that. Okay? We have a general, this was just general, right? Okay? All right. Anybody get left behind on that problem? All right. So things get pretty crazy. We're going to have some ln going on here. All right. This was back to a specific solution. Y prime needs to be written how? UIDX. Okay. So you can separate. All right. I'm going to pause it again. To separate, I'm assuming you factored. Okay, because then that's x is separate from y's, which is the whole plan. Okay. Now again, we're going to have to get that y minus 1 over here. And okay. First inclination was anybody to add the x to both sides? We really want, anybody want to do that? Dy dx plus x. What the heck are we going to do with that? Got to be multiplication so we can integrate. All right, here we go. Integration. Okay, so here's that u business. U is y minus 1. Du is the same as dy. So this becomes 1 over u du, correct? And what's the antiderivative of 1 over u du?
Thank you for saying absolute value, Emma. You're the best. Okay. All right. And the antiderivative of x is plus c. Don't forget your c, girl. Okay? All right. Now, we got to put in our y because you made up. All right. So here we are. Anybody have an issue with how we got to there before we go from here? Okay, now how do we solve for the y, which is part of the ln? Do the e power. Good job. There's an e right there. E to the s squared over 2 plus c equals absolute value of y minus 1. Okay? Now, is e to, what do we know about e to any power over here? Just generically, what do we know? Thank you, Hannah. Good job. It's going to be positive. So then we can drop off our absolute value bars. Because if we couldn't drop them off, we were like, what are we going to do with that? Now, okay. Now, there is one little detail besides you're adding 1, which I think many of you got to this point, which is awesome. Okay? This C, whoa, is just weird. I don't know what that is all about. This C right here is just weird. Okay, so we're going to take care of that and write it a little bit differently. Remember this, side note here, is this, correct? Okay. E to the C is also known as a constant. Okay? Now, I'm not going to use the same C that we've been using. We're going to use a K. So this is e to the x squared over c times k, which we will write this like this. E k times e to the x squared over 2 plus 1 equals y. That is our general solution. Did I lose anybody? Over 2, sorry. Thank you. Yes, I did. Thank you. I heard her little voice correcting me, but I just ignored it, Lindsay. Thank you. Oh. Okay. To call it C again would be weird and confusing, so that's why they go to the K. That's pretty typical. All right, now go ahead. Plug in your specific solution. 0, 3 means x is 0, y is 3. Okay, x is 0, y is 3. And we're looking for k. Back in the general solution. Okay, e to the 0 over 1. All right. The next page shows the slope field of xy minus x. That's all this background. And then y1 superimposed on it is 2 e to the x squared over 2 plus 1. You can tell it perfectly fits the slope field that we have through 0, 3, which is probably right here, I'm guessing. Okay? Actually, no, it isn't. What's my point? It's weird. Maybe I have it imposed differently. I must. I don't know. Anyway, okay. Try another one. When it says solve and it doesn't give us a specific solution, we are looking for what? General solution. Okay, go for it. Come on. Change to dy dx. You separate, it looks like this. Your dx comes over here. Has to be multiplied so we can integrate. Don't forget your absolute value, just as a precaution. Now e to the equals absolute value y. This is positive again, so this drops off. And then x to the c is k. There's your general solution. Okay? Questions? Yes.
Will there ever be a time
Yes. But in this case, if it's e to a power, any power is going to be a positive. Because depending on what, e to a power positive, e to a power negative is still going to be one of those two. So, but yes, I would not say, oh, I'm not going to remember that, so I don't have to worry about that. Yes, maybe not in these type of problems because you're always going to have e to a powers to get to y, but certainly it's going to come up. So just two ways. Okay? Yes. Yeah. All right. Okay, there's another specific solution. This one has a little trick too. I'll see if how many of y'all catch it. So here we go. Let me get to the point where you all made a mistake. Because it wasn't here. It wasn't here. It wasn't here. It was here. I just made a mistake. What is it?
Oh, is it just x
No.
plus c?
No. That's it. Okay, this is the general solution. Okay, now, why does that matter? Because look at your solution. We are plugging in a 0, -3 for xy. Okay, so here we go. -3 equals plus or minus 0 plus c. I'm going to square both sides. So you're like, well, why does that even matter? Because c is 9. Okay. So what's my? This is two solutions. Just saying. Pick one. Not any one. Negative. Why negative, you Faye? Because the y is negative. That's the only way the y is going to be negative if this thing is here. That's a negative sign if you didn't think that was because of its direction. Let me try again. Does that make sense? Because that's going to be the number 1, and because you all didn't think about this right here, you missed it. I was shocked. Yes. I was shocked that you all didn't think of that when you did that. Okay. So when you get this and you have your plus or minus, and then you are like, okay, let's just throw in our x and our y. We square both sides and we get this. We get c equals 9. And then we go back to the general solution, remember, which is plus or minus. We have to pick one because that's two solutions. That's this or this. Those are your two general solutions. Okay, remember a general solution is a family of solutions. All right, in order to plug in to get 0, -3 out of our equation, really ugly. We're going to have to pick the -1 because the y is negative. So that's why we had to pick that one. Okay? That's the trick that I was alluding to there. All right? That makes sense? Okay, so that's going to be something you got to really be careful of. Get your plus or minus going. That'll give you a visual of, oh, is it plus or is it minus? It depends on what the negative is. All right. Now, this last one is from the non-calculator part of AP test that I picked it up, I don't remember what year it was. It is intense. And I was trying to figure out, those are your solutions, your choices, A, B, C, D. There's your DiffyQ over there on the left, and your initial value y1 equals 4. All right, now, originally I thought, well, why don't I just plug in to see if 1, 4 works in these, okay? Instead of the whole big process, I don't think it saved me any time, because I think I had to eliminate one of those choices. So basically, my list, you can think of a better way, basically just solve that DiffyQ.
You said no calculator.
Correct. Why, did you have a plan if you had a calculator? Did you have something that you could have done? Okay, so go for it. I'm trying to stay in front so you don't. You got it. I went to here and then I was like, I'm going to stop just because this is different. So what did you do to get the 2y down below? ln of both sides. Okay, so ln of e to the 2y becomes 2y equals ln of 2x cubed plus c. Okay, now I saw some of you are putting absolute value bars. Is that necessary? No. But it should be necessary to do that. Okay? And then you divide your 2. I don't know how you want to express that, but probably this is best to put the 1/2 there instead of over 2. You'll want to do that eventually. Now, what's my specific solution? 1/4. Okay. So here we go. 1 goes in for x. So this is 8. No, it's 2. 2 plus c. And 4 goes here. Okay, right? So far, so good? So multiply by the 2. Now, here we go back. We got to find the c again. So what do we do? E to the 8th equals 2 plus c. C equals e to the 8th minus 2. Okay, everybody get there? So here's your general solution. And the C, and I'm just gonna. Okay, and by now you've figured out that it is choice D. Okay? Any piece of that need to be done again. I did a good job with your LNs, all that. Beautiful. Okay? So you can go back and forth. Now, I want to do one more thing. It's not on your slide. But I want to bring back, not way throwback, but bring back 7-1. Confirm that y equals 1/2 ln, what was it, 2x cubed plus e to the 8th minus 2, is that right? Is a solution of dy dx equals 3x squared e to the negative 2y. This is intense confirmation, but we can do it. All right, so where do we start? Remember, confirming is taking this to PQ and throwing in the solution and making sure that that is a true statement. So which side of that DPQ should we start, left or right? Right, for sure. Okay, so 3x squared e to the negative 2y. Okay, we're going to plug in our y. All right, 3x squared e to the negative 2. Our y is 1/2 ln 2x cubed plus e to the 8th minus 2. Okay? What does that become? First thing I'm going to do is, anybody want to read my mind here? Cancel the 2's, good. Okay. I'm just going to rewrite it. I wouldn't have to, but I think it'll make the next step easier to see if we rewrite. It's ugly, but it ends up. Oh, okay. Thank you. All right. Can we do something with that negative ln? Because if it was e to the ln of blah, 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 this would be blah, blah, blah. But that negative kind of throws a little kink in that whole statement. So what can we do with that negative? Put it in front. It's already in front. I want to get it out of front. Where does it go?
3x squared over e.
Say that again.
3x squared over.
Well, technically, here's what you're doing. 2x cubed plus e to the 8th minus 2 to the negative 1 power. Remember, a factor out front is an exponent. Okay? All right, now these will cancel each other. And yes, that's what we'll have is, so technically that's what Emma was saying, right? All right, now, we're supposed to end up with dy dx. Well, I guess we need to find what dy dx is, right? So dy dx, y equals 1/2 ln 2x cubed plus e to the 8th minus 2. Okay. What is that? How do we do that? I can take a derivative of that it?
And on the top, it's going to be 6x squared.
Very good. Yeah, those are constant because that's all constant. Nice. That's u substitution.
Oh,
1/2 ln u. U is that mess. Okay. 1/2 ln u is 1/2 of 1 over u. That's this. And then the derivative of u is the 6x squared. Nice work. All right. Clean it up. What do we got? 2 goes into 6 3 times, so I got 3x squared. Well, looky there. So there's your proof. That is indeed dy dx. Done. Okay? But you can't just assume that that's dy dx. You would have to show me what dy dx. That could definitely be a free response problem. Confirm. Okay? Make sure you spell everything out. They like the confirmation. Sometimes they give you these nasty double derivatives that are confirming. You just got to get to where they got to. They're not trying to trick you. They're not saying, oh, it's not the same. Yes, it is. You've made a mistake. Find it. Okay? So the confirmations definitely do